Okay, hi guys, here we are on day 2 of factoring. Yesterday we looked at factoring polynomials in the form of ax squared plus bx plus c, where this number here was equal to 1. And so today, in factoring day 2, we're going to look at what happens if we have a polynomial where a is bigger than 1. And there's a couple little extra steps involved, but basically it's the same thing. So let's go ahead and get started. Okay, as I said previously, this is the second type of polynomial we're going to look at, and again, this is in standard form, and we're going to look at polynomials where a is bigger than 1. So if you look at this polynomial, 2x squared plus 11x plus 12, we have the number 2 here. So how do we factor this polynomial if there's a 2 here? How does that affect the middle term? How does that affect the last term? Or does it affect the middle term and affect the last term? So at this point, I just want to work through this example with you. We're going to multiply the x squared term with the constant term. So what we're going to do in this step right here is we're going to multiply a and c. And when we multiply a and c, we get 24. We're going to split the 24x squared into two terms that add to 11. So just like yesterday, I want factor pairs of 24 that add up to 11. So I need factor pairs of 24 that will add up to 11. And the factor pairs that give me 24, if I multiply 8 times 3, I get 24. And if I add 8 plus 3, I get 11. So that's what I'm looking for. So we need terms that add up to 11, which is this term right here, and multiply together to get 24. And the first term in the polynomial we just bring down, and the constant in the polynomial we just bring down. And so our 8 and our 11 are in here. So now I have 2x squared plus 8x plus 3x plus 12. So I'm going to break this into two parts. My first part is 2x plus 8. And I need to factor that. And my second term is 3x plus 12, and I need to factor that. And I'm factoring that by finding the GCF. So if I look for the GCF of 2x squared and 8x, that GCF is 2. And when I divide everything, when I divide this by 2x and divide this by 2x, that's going to give me 4. And that's going to give me x. So I have 2x times the quantity x plus 4. I'm going to do the same thing with 3x plus 12. What's the GCF of 3x and 12? The GCF of 3x and 12 is 3. So I'm dividing this term by 3, that's going to give me x, and this term by 3, and that's going to give me 4. And if you notice, what I end up with right here is I have an x plus 4 here, and I have an x plus 4 here. So I'm just going to bring that x plus 4, and I'm going to bring it down right here, because what I did is I found one of my factor pairs for the polynomial 2x squared plus 11x plus 12. The rest of the term, the second factor pair, comes from the GCFs. So the GCF of the first term was 2x, that's right here. The GCF of the second term was 3, and that's right here. So my factored form of 2x squared plus 11x plus 12 is x plus 4 and 2x plus 3. So let's work through an example over here. Let's take a look at example 1. Okay, in example 1, we need to factor 10x squared plus 17x plus 3. So first we want to find, I'm just going to rewrite it. So we have 10x squared plus 17x plus 3. I'm going to bring down my 10x squared, bring down my plus 3, and then I'm going to multiply a and c, and I get 30x squared. So I need factor pairs of 30 that are going to add up to 17. And factor pairs of 30 that add up to 17 are 15 and 2. So this is going to leave me with 15x plus 2x. So now I can group these two and I can group these two. And now I need to factor, find the GCF of 10x squared plus 15x. And the GCF of 10x squared and 15x is 5x. And if I divide each term by 5x, this leaves me with 2x, and 15x divided by 5x leaves me with a plus 3. I want to do the same thing for the second one, and this one doesn't have a GCF, this one right here, so I'm just going to rewrite 2x plus 3, but I'm going to put a 1 here, so if you can't find the GCF, just put a 1 out there. So our first polynomial, or binomial, or factor pair is 2x plus 3, and then my second one is 5x plus 1, and so that's times 5x plus 1. So the factored pair, the factored form of 10x squared plus 17x plus 3 is 2x plus 3 times 5x plus 1. Go ahead and try example number 2. And then pause the video and check your answer, or you can just follow along with me. So we're going to factor 10x squared plus 11x minus 6. And again, we're going to bring the 10x squared down, the first term, and the last term is minus 6. We're going to multiply the coefficient of x squared and negative 6, and we get a negative 60x squared. So I'm looking for factor pairs of negative 60 that add up to that middle term, which is 11. And I can use 15 and negative 4. 15 times negative 4 is negative 60, and 15 plus negative 4 is 11. So this will give me 15x plus a negative 4x. So these are the two sets of terms that I want to factor. So I need to find the GCF of 10x squared and 15x, and that GCF is 5x. If I factor out 5x, that gives me 2x. 10x divided by 5x is 2x, and 15x divided by 5x is 3. And I want to do the same thing for the second one. This is plus. I want to find the GCF of negative 4x and negative 6, and that GCF is negative 2. Negative 4x divided by negative 2 is 2x, and the negative 6 divided by negative 2 is a positive 3. And so when you're doing this, look at these in parentheses. If you have this term right here after you take out the GCF, this one should match it if you're doing everything correctly. And so our first binomial for our factored pair is 2x plus 3, and then our second binomial for our factored pair is 5x minus 2. And so the factored form of 10x squared plus 11x minus 6 is 2x plus 3 times the quantity 5x minus 2. Okay, last example. So in example 3 we have x squared minus 64. How does this polynomial different from the others? Well, how is it different? It's missing the middle term. And can it still be factored? I'm going to say yes, since it's on here, it probably can. And that middle term that it's missing is always going to be 0x, because 0 times anything is 0. So we're going to go ahead and factor x squared minus 64. So we're looking for factor pairs of negative 64 that add up to 0. And those factor pairs are negative 8 and 8. Negative 8 times 8 is negative 64, and negative 8 plus 8 is 0. So our factor pairs of x squared minus 64 is x minus 8 and x plus 8. So our last example here, 3c squared minus 75. We want to look for the GCF. the GCF of these two terms is 3. So for 3c squared minus 75, I'm going to divide each term by the GCF. And when we do that, there's our GCF, c squared minus 25. Now we're left with one like example number 3. What are the factor pairs of negative 25 that add up to 0? And those factor pairs are 5 and negative 5. And if you had it as negative 5 and 5, it would get the same thing. So keep the GCF, and the factor pairs would be, or the factors would be c minus 5 and c plus 5. Okay, now it's your turn to answer 2 questions from the notes. In number 1, multiple choice, you need to factor the polynomial 4y squared plus 14y plus 6. And as with everything, first thing you want to do is there a GCF? And if there is, you need to factor that out. Factor out the GCF, and that greatest common factor has to be common to every single term. Same thing with number 2, is there a GCF? And if there is, it has to be in common with every single term. Be sure to enter your questions on the Google form, and if you have any questions, you can put those in there as well.